Hi, this is Calandra. In this video, we'll go over function notation and how to evaluate functions. An analogy commonly used for functions is a machine. So think of a function as a machine where x represents your input. So when you put x into this machine, this function, and let's let f be the name of the function, then the output is going to be denoted f of x. Okay, so that's the way that you read that, f of x. It does not mean f times x. This just means that you substituted x as your input into the function f. Well, you may remember from a previous video that the output of a function is also commonly represented by the variable y. So this new notation f of x is the same thing as the single variable y. The benefit of using function notation is that it enables you to see what your input was to result in your y value. So in our first example, consider the function f of x equals x squared minus 2x plus 4, and we want to find the following. So part A, we want to find f of 3. So notice that this 3 is in the same place that the x was in our definition of the function. So that means that we're going to substitute 3 in everywhere we see an x on the right side of the equation. Okay, so f of 3 is equal to 3 squared minus 2 times, instead of x, we now have 3, and then plus 4 on the end. And now we just have an order of operations problem. So 3 squared is 9. I have minus 6 plus 4. So 9 minus 6 is 3, plus 4 is 7. Okay, so we found then that f of 3 is equal to 7. The benefit of that notation is that I know to get this y value of 7, my x value was 3. So I could even write my coordinate from this information. I know the point 3, 7 would lie on the graph of f of x. Okay, for part B, we want to find f of negative 1. So now we're substituting negative 1 everywhere we see an x. So we're still using that same function f. So instead of x squared, we have negative 1 squared. Very important to put that negative 1 in parentheses because you want that entire quantity squared, not just the 1. Minus 2 times negative 1 plus 4. And now we just have an order of operations problem. Doing our exponent, negative 1 squared is 1. Negative 2 times negative 1 is positive 2 plus 4. And it looks like we end up with 7 for our answer again. So we found f of negative 1 equals 7. So again, that means we know that the point negative 1, 7 is on the graph of that function. Okay, for part C, we want to find f of a plus 1. So even though this looks a little bit more complex, we're still going to follow the same method to evaluate it. This just means we're going to substitute a plus 1, that entire quantity, everywhere we see an x in our f equation. So instead of x squared, we have a plus 1 quantity squared. Minus 2, instead of times x, it's times a plus 1. And then we have plus 4 on the end. Okay, the first thing I'm going to do, and hopefully you will remember, a plus 1 squared means that we have a plus 1 times a plus 1. So we need to use the FOIL method, or some form of the distributive property. Okay, I'm going to go ahead and distribute my negative 2. So I'm going to have a negative 2a minus 2, and then we have plus 4 on the end. Once you use FOIL, you should end up with an a squared plus 2a plus 1. We still have minus 2a. We can go ahead and combine our minus 2 plus 4 to get a positive 2. So notice that the 2a's cancel out, and it looks like our simplified answer will be a squared, and we have 1 plus 2, or 3.